This is Bob Capetta from the College of the Florida Keys, and this lesson is on ellipses. So what I have here is an ellipse, and each ellipse has a focus and another focus. And you want to think of this as a pair of push pins in a bulletin board. And then there is a string that is tied to the two focuses or foci. And you'll notice that the distance is always the same, the length of the string. So this first distance here plus the second distance here is constant. So if we're looking from this point, this distance from here to here, distance one, the distance from F to P prime is the same as the distance from F prime to P prime. Same thing here, this distance plus this distance, the sum of the distances are the same. So an ellipse is the set of points such that the sum of the distances from the two focus points is constant. So how do we graph one? So that's our geometric definition. And we'll keep that in mind. But we'll take a look at the following example. If I have x squared over 25 plus y squared over 49 equals 1. This is the form that we like. The center of the ellipse is at 0, 0. And you'll see that we'll eventually move off the center a little bit. Now we have 5 squared downstairs, so we rewrite the equation as x squared over 5 squared plus y squared over 7 squared equals 1. The 5 and the 7 are going to be important. In the x direction, from the center, I go 5 in that span, 1, 2, 3, 4, 5. This will be a vertex or a point on the end, 1, 2, 3, 4, 5, another point on my ellipse. In the y direction, we go up and down 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So those 4 points will help define our ellipse. We want to go ahead and draw that oval around those 4 points. What will that look like? So we do our best to hand draw something that fits that fairly well. And we have our hand-drawn ellipse. But remember what we said. We said the ellipse was the set of points such that the sum of the distances from the two focal points is constant. So where are the focal points on this ellipse? Well, one thing to keep in mind is that the focal points always are on the major axis. What does that mean? The longer of the two parts. So in this situation, the major axis is the y-axis, the vertical axis. So in this case, it's vertical. So the focal points are somewhere along here because this goes up and down 7, as opposed to in the x direction, it goes over and over 5. So somewhere on that vertical piece on the y-axis will be my focal points. Now, how do we find those? Well, I use the following equation. C squared equals the larger denominator minus the smaller denominator. We want to think of these things as perfect squares. So I say the bigger of the two squares minus the smaller of the two squares. So the bigger of my two squares here is 49. So C squared will be 49 minus 25. So what is that going to be? C squared is going to be 24. So knowing that C is the square root of 24. So that is 4 times 6. C is 2 root 6. Obviously very close to 5. So let's go ahead and draw our focal points in. Almost 5 on the major axis here. Almost 5 on the major axis here. So if I pick any point on the ellipse, the distance from one focal point plus the distance to the other focal point has to be constant. Distance from one focal point to the other has to be constant. Distance from this focal point plus distance from this focal point has to be constant. That's our definition. So we're going to want to be able to graph these things, and we're going to want to be able to identify where the focus points are in this problem. So in terms of our vertices, where are they? Some textbooks say the vertices are only on the major axis. Other textbooks say they're all four that define the ellipse. So I'm going to just go ahead and give you all four vertices. The vertices here we have 0, 7, 0, -7 on the major axis. On the minor axis, we'll say 5, 0, -5, 0. And regarding the foci, the focal points, where are they? 2√6, so 0, 2√6, and 0, -2√6 will be our two focal points. So that's where the push pins go. We connect the string, and then we draw all the way around to create our ellipse. So in this example, our major axis was vertical. Why is that? Because the larger number, the larger denominator was under the y² version of this problem. Okay, let's try another one. This time, let us do x² over 64 plus y² over 16 equals 1. What we're going to do here is we're going to rewrite this as x² over 8² plus y² over 4² equals 1. So the center is at 0, 0 again. That hasn't changed. My span in the x direction, over 8, back 8. Over 8, back 8. My span in the y direction, up 4, down 4. So that could give me my four vertices if we want to go ahead and list those now. The vertices on this ellipse would be 8, 0, -8, 0. They make up the major axis, that's the longer part, as well as 0, 4, -4, 0, 4, 0, -4. So once we have those points, we can go ahead and draw in the ellipse. So I will do that next. Let's try to draw in that ellipse. And then lastly, we want to go ahead and find the focal points. Where are the two focuses, the two foci? c² is the larger of the two denominators minus the smaller of the two denominators. So I could say big square minus small square. So in this case, the big square is 64, the small one is 16. 64 minus 16, so I believe I get c² is 48, which would mean that c is the square root of 48, which I believe is 16 times 3, right? 16 times 3, so 4√3. And square root of 48 is very close to the square root of 49, so it's very close to 7. So let's go ahead and put our two focal points in on our graph. So we'll put one very close to 7 here, one very close to 7 here. So that's where our two focal points will be, and it's kind of obvious to see the distance from there to there plus the distance from there to there is the same as the distance from this focal point to this vertex plus the distance that focal point to that vertex. So what is the location of our two focal points, our two foci? On the major axis this time is horizontal, so it will be -4√3, 0, and +4√3, 0. Well, the two examples we've looked at today have both been centered at the origin. Of course, we can move off the origin to get our location of an ellipse. And that's going to change how we're going to find our vertices. That's going to change how we're going to find our focal points, our foci. So let's take a look at that next. So if I have a situation like this, like x minus 3 squared over 9 plus y plus 4 squared over 16 equals 1. Our vertex this time is what x do I need to have this behave like a 0? And that would have to be 3. What y do I need to have this behave like a 0? That would be -4. So my vertex here is the x value is going to be 3. The y value is going to be -4. So let's go ahead and put that in. 1, 2, 3, 4. So that's our vertex. In the x direction, our span will be 3 because we'll rewrite this as x minus 3 squared over 3 squared. So my span in the x direction is 3 plus y plus 4 squared over 4 squared. My span in the y direction will be 4 equals 1. So starting at the center, moving 3 units, my span in the x direction is 3. Moving 3 units in the x direction both ways, we get 1, 2, 3 here, 1, 2, 3 here. In the y direction, our span is 4. 1, 2, 3, 4. 1, 2, 3, 4. So our ellipse this time is not centered at the origin. Our ellipse is centered at 3, -4. So we will go ahead and do our best to draw that. And then we're going to look for where the 2 focus points are. They will be on the major axis, which is the major axis here. This one, that's longer, 4 and 4 versus 3 and 3. The major axis this time is vertical. So we're going to use our rule. C squared is the larger squared minus the smaller square. Big square minus small square. Our big square is 4 squared minus our small square is 3 squared. So I get c squared is 16 minus 9, which is 7. So c is √7 or plus or minus √7. So that means I have to go up and down √7 from my vertex. Remember, my vertex was 3, -4. So my first focus, starting at my vertex and going in the vertical direction, 3, -4 plus √7. My second focus would be at 3, -4 minus √7. So let's get decimal approximations for where those will be on the graph so we can visualize where those 2 focal points will be. So we'll take -4 plus √7 is about -1.35. So -1.35 around here for one of my focal points. And for the other one, 3, -4 minus √7 is about -6.65. -6, 1, 2, 3, 4, 5, 6.65, somewhere around there is my second focal point. So again, remember, if we would tie a string at those 2 push pins, tie a string to this one, and then put our pencil and then wrap that around, the distance, the sum of those 2 distances is constant, and that's what's going to enable me to trace out that ellipse. And that will conclude this lesson.